All right, so now we're going to take a little deeper look at the electrons in atoms, because the electrons, the location of the electrons and the electrons themselves play a big role in the properties of the elements and their reactivity. All right, so we're going to take quite a simplistic, simplified view of where the electrons are. If you go a little bit further in chemistry, we're going to make it a little bit more complete picture, but the picture we're going to give you now will suffice for what we need to do. Okay. In the 1920s, quantum mechanics and quantum theory gave us information about the atom, telling us that electrons could only have specific energy values. Remember, they're particles and they're moving around, so they've got energy. And they're being attracted to the nucleus. So they have both kinetic energy because they're moving, and potential energy because there's an attractive force working on them. So quantum theory says that electrons can have only certain energies, and those energies are going to be defined by the level that the electron is in. So we're going to call these things that electrons are in energy levels, and we're going to abbreviate energy levels with the letter N. Okay? Remember, when we're looking at atoms in the periodic table, the atomic number, the number that's on top of the elemental symbol, is the number of protons. But since we're talking about atoms, the number of protons and the number of electrons are the same. So when we look at a periodic table and we want to figure out the number of electrons in the atom that we're dealing with, we can just look at the atomic number. Okay. So on the right here is kind of the depiction of the energy levels. The lowest energy level is the n equals 1 level, and then it goes up n equals 2, n equals 3, n equals 4. And you can see that as you go higher and higher, the difference in energy between the levels gets less and less. But as we go higher, the difference in the energy levels the energy goes up. So an electron in the n equals 4 level has more energy than an electron in the n equals 2 level. Okay? And if we think about electrons in atoms and the nuclei are positively charged and the electrons are negatively charged. So they're attracted to each other. So electrons with more energy can get farther away from the nucleus because they can overcome that attractive force a little bit. So we would expect the electrons in the n equals 4 level to be farther away from the nucleus than the electrons in the n equals 3, n equals 2, or n equals 1 level. Okay? So as you go up in energy, the electron can get farther away from the nucleus. The energy levels can only have a certain number of electrons in them. For example, the n equals 1 level can have 2 electrons in it. The n equals 2 level can have 8 electrons. Then n equals 3 level can have 18 electrons, and so on. And that number is determined by 2n squared. So for example, when we're in n equals 1, n squared, 1 times 1 is 1, times 2 is 2. So that's where we get the maximum number of electrons. For the n equals 3 level, n squared, 3 times 3 is 9, 9 times 2 is 18, so that's where we get that. All right, so rules for filling the levels. What we're going to do is this thing called ground state electron configurations, which means we're putting the electrons in the lowest possible energies that they can go in. So we're going to start by putting electrons in the n equals 1 state. Once that has 2 electrons, remember, because I can only have 2 electrons, then we go to the n equals 2 state. Once that's filled with 8, then we go to the n equals 3, the 3 level, and so on. Okay, so we're just going to fill the lowest level first, and then once that's full, we're going to move to the next one, fill that one, and so on. So we can see hydrogen. Hydrogen has 1 electron in it, so that goes in the n equals 1 level. Helium. Helium has 2 electrons. Those 2 electrons can both go in the n equals 1 level because it can hold 2 electrons. Lithium has 3 electrons. Lithium atoms have 3 electrons, so 2 of them are going to go in that n equals 1 level, and then one of those are going to go in the n equals 2 energy level. If we draw them, if we depict these in kind of orbits, we can say hydrogen has, in each of these circles is an energy level. So that's the n equals 1 level. And then we put the next one here, n equals 2 out here, and so on. So we would depict an electron as a black dot. So for hydrogen, there's 1 black dot in the n equals 1 level. For helium, there's 2 black dots in the n equals 1 level. For lithium, there's 2 dots in the n equals 1 level, and then 1 dot in the n equals 2 level. Okay. The electrons in the highest energy level are called valence electrons, and those that are not in the highest energy level are called core electrons. So basically, electrons that are not valence electrons are the core electrons. So valence electrons are the ones that are farthest away from the nucleus, and those are the ones that are going to do interactions with other atoms. So we can see that hydrogen has 1 valence electron and no core electrons. Helium has 2 valence electrons and no core electrons. Lithium has 1 valence electron and 2 core electrons. Right? So the valence electron is in the outer level, and then the core electrons are any electrons that are not in the outer level. So if we look at the electrons in atoms, we can see that in the first level, the n equals 1 level, we have the hydrogen and the helium. In the n equals 2 level, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. In the n equals 3 level, we're going to have that whole row, and then some other ones, but we're not going to worry about the other ones. So for this class, we're going to only worry about the first 3 rows. Again, if you go on in chemistry, we'll go a little bit farther than that and discuss more things, but we've taken a pretty simplified view, and to go to those other ones, we need a less simplified view. Alright, so if we want to do this for electrons with more atoms, for example, nitrogen, if we look at nitrogen on the periodic table, its atomic number is 7, so it's got 7 electrons. So 2 go here. No, it doesn't have 7 electrons. Yeah, it does. What am I doing? Wow, there's way too many here. So these 2 shouldn't be there. Get rid of that, get rid of that. And then 2 of these shouldn't be there. Get rid of that and get rid of that. Okay? So nitrogen should have 7 total electrons. It's got 7, it's got an atomic number of 7, so it's got 7 protons, 7 electrons. So the first 2 electrons go here, and they go in the inner energy level, and then the last 5 go in the n equals 2 level. So 1, 2, 3, 4, 5. And that means there should be 5 in that n equals 2 level. What about sodium? Sodium has an atomic number of 11, so that means we have 11 electrons that we need to do. So 2 of them go in the n equals 1 state, and then 8 of them can go in the n equals 2 state. 2, 3, 4, 5, 6, 7. And that gives us 10. That means we have 1 that has to go in the n equals 3 level. So if we're putting them in here, so there's 1, 2, and then we got to put 8 here. 2, 3, 4, 5, 6, 7, 8, and then 1 out here. So how many valence electrons in sodium? Only one, right? That one right there. The one that's in the outer energy level. How many valence electrons in nitrogen? 5. There's 5 valence electrons in nitrogen because there's 5 in the outer level there. Okay. So if it's not a valence electron, it's a core electron. So in sodium, there's 1 valence electron and 10 core electrons. And in nitrogen, there's 5 valence electrons and 2 core electrons. Okay. What about chlorine? If we look at chlorine, chlorine has 17 electrons. That means 2 go in the n equals 1 level. 8 go here. That's 10, and that means 7 go in this n equals 3. Okay, and if I'm putting those in here, 2 of them go in the n equals 1, 8 of them go in the n equals 2, and then 7 of them go in the n equals 3. How many valence electrons in chlorine? Right there, all of those, right? There are 7 valence electrons in chlorine, and the rest of them are core. So there's 7 valence electrons and 10 core electrons in chlorine. Okay. So if we want to break that down into a little table through the first 3 rows in the periodic table, for hydrogen, there's 1 electron in the n equals 1 and none in the n equals 2 or n equals 3 levels. For helium, there's 2 in the n equals 1 and none in the n equals 2 or n equals 3. For lithium, 2 of them go in the n equals 1, but then we still have 1 more, so it goes in the n equals 2. Okay, and so on. And you can see the next 8 go in the n equals 2. And that gets me to the noble gas neon. And then I go down to the next row, which starts with sodium in the periodic table. The n equals 1 and n equals 2 levels are full. So then I start in the n equals 3 level. And I just put electrons in the n equals 3 until I get to argon. All right. So let's do a little practice. How many electrons in each energy level for each of the following atoms? So helium. Helium has 2 total electrons. Cool. Let's take a pause. You got to do this first and then come back and see if you did it right. So take a minute, try this yourself, and then come back. Alright, so hopefully you paused and did this yourself. So let's continue. Helium has 2 electrons. So that means there are 2 electrons in the n equals 1 level. Right? Because that's the only 2, and the n equals 1 level can have up to 2 electrons. Carbon has 6 electrons. 2 of them are in n equals 1. Because that fills it up. And then there are 4 electrons in the n equals 2. Because n equals 2 can take up to 8, but carbon only has 4 to put in the n equals 2. Aluminum has 13 electrons. So again, it has 2 electrons in the n equals 1 level. It has 8 electrons in the n equals 2 because n equals 2 can take 8 total electrons. And then there's 3 left, so that means there's 3 electrons in the n equals 3 level for aluminum. Neon has 10 electrons. Neon atoms have 10 electrons. Again, 2 electrons in the n equals 1. 8 electrons in the n equals 2. So 8 and 2, 10 total, and that's all the electrons we need to do. And then phosphorus has 15 electrons. 2 of those electrons go in the n equals 1 level. 8 of those electrons go in the n equals 2 level, and then there's 5 left over, so 5 electrons in the n equals 3 level. Okay, and then the easiest way to look at valence electrons are the ones that are the farthest or in the highest level for each atom. So for helium, those 2 are the valence electrons. For carbon, those 4 are valence electrons. For aluminum, there's 3 valence electrons. For neon, there's 8 valence electrons. And for phosphorus, there's 5 valence electrons. So the number of electrons in the highest energy level is how many valence electrons there are. Okay? So if we want to do the diagram for phosphorus over here, so for phosphorus, there's 2 electrons in n equals 1. There's 80 electrons in the n equals 2. And then there's 5 electrons in the n equals 3. So doing that here, we do 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. And then 5. I like to space them out because that's how I do it. And then 5 in the n equals 3. Right? So kind of an introduction to where electrons are in atoms. And honestly, it's the valence electrons that are going to play a big role in everything, in interactions with other atoms and bonding and all that. So an understanding of where the electrons are, along with how many valence electrons an atom has, is really important.